Department of Chemistry. Today I am going to take about on the topics of determination of strength of HCl using potentiometer. Okay, so by this we are using this two electrodes for this experiments. One is a kilomole electrode and another one is a standard kilomole electrode. So the electrode which is we are using is the one is a platinum electrode which is used for the conductance of the current, and the kilomole electrode which is consist of this HCl, saturated HCl, and the mercury is dipped in mercury solution, mercurous chloride. Over that the filled with a platinum wire which is connected through this platinum electrode. Okay, so the formation of this kilomole electrode and the platinum electrode which is considered for this potentiometer experiments. Now I am going to take about the burette solution as what is the burette solution?
Standard potassium dichromate.
Standard potassium dichromate. Okay, and what is the pipette solution?
FAS.
FAS, that is ferrous ammonium sulfate. And what is the additional solution we are adding in this experiment?
Dilute H2SO4.
Dilute H2SO4. So dilute H2SO4 which reacts the reaction and follows the FAS, that is ferrous ammonium sulfate, into a ferric. We are converting the ferrous into a ferric solution by using this potentiometer experiment. So the aim of this experiment is going to do the strength. We are going to identify the strength of an experiment for this ion into a Fe2 plus. Fe into an Fe2 plus we are converting this experiment. So for this I am adding just the potassium dichromate in this burette solution for this experiment. So and the pipette solution is FAS, that is ferrous ammonium sulfate solution. I am adding 20 ml of ferrous ammonium sulfate solution. And dilute solution of, additional solution of dilute sulfuric acid. So total solution of 40 ml of solution with this zero reading of the burette solution of potassium dichromate. I am adding this two electrodes. One is a platinum electrode and another one is a kilomole electrode. So with this zero reading of potassium dichromate, the constant value for this solution is 350 values. So we are noting this equation with this volume of potassium dichromate and the EMF value is noted from this potentiometer. So for this, the zero reading from 355 to the values will be increasing slightly more. So 350, 380, 3600, and the sudden increases with the values of the 800 to 1000 values, the change in value from Fe2 to Fe2 plus. So this is the reaction follows from this value. From this value we are calculating this what is the EMF value, and EMF can be calculated to a del E, del pH and del E by del E. What is the delta value and divided by the volume of concentration of this sample solutions. So okay, and both the solutions can be calculated by this mean volume. How the mean volume is calculated for this is 0 readings to 10 readings. How the values can be increases from 0 to 12. Okay, so with this reading we are going to plot the graph from this. Two graph we are plotting. One is the volume of potassium dichromate and another one for the x-axis is EMF values. So plotting this graph we are getting this what is the strength of HCl for using this Fe and Fe2 plus. And another graph we are plotting for this volume of del E and del V and mean volume. So with this we can also calculate this what is the correct value for the strength of acid. Okay, that is Fe and Fe2 plus. So from this both the graph we are midpointing the values of Fe2 plus and we consider the volume for potassium dichromate, and we are finally we are going to consider the volume of Fe2 plus ion, that is Fe2 plus ion, how the strength is calculating from this potassium dichromate. So for using this plotting the graph, the calculation of the values we are calculating for the formula of V1 A1 by V2. So V1 is already we have identified, that is we are taking a 20 ml of solution and 20 ml of the sulfuric acid and divided by this total volume of 20 ml of pure solutions. So okay, so we are considering the strength of FAS into equivalent weight divided by 1000. So this is the formula for calculating this value. Okay.